Okay, I'm back with Iron Man and Bumbleboy over here. We're going to do yet another problem where we have to get the derivative, critical values, and intervals of increase and decrease. So you start with your derivative. And this one's got to be a quotient rule, so get yourself ready for some d high, less high, d low. And I'm going to do as much simplifying as I can here. Over the square of low we go. So there's the setup for quotient rule. And I always start with that low component, x squared minus 9, and d high, the derivative of the top, which is 2x. Sorry, it's so tiny in the font. And then less high, low d high, less high, d low. So you get that x squared is the high that goes here. And d low, since it's x squared minus 9, it's just 2x. And over the square of low we go. So it's x squared minus 9. You have to go over there, honey. You can do it. Just go over and turn the switch off. Okay, Ethan, will you listen to your brother? He wants certain lights on, okay? Ooh, that's cool. Okay, just listen to each other. And then we have, there's your derivative, ready to go. So the first thing we do, hey, when is it equal to 0? The derivative, that is. Okay, that's one thing we have to figure out. And also, when is it undefined? And we'll start with when is it equal to 0. And if you remember back to some of our conversations in class, we really only are concerned with when is our numerator equal to 0, because if the numerator is 0, the whole rational expression is 0. So if I just deal with that, then I've got some good stuff going on here. So I'm going to look at that numerator, which needs some simplification. So if I go over there and do a little work to distribute the 2x and multiply these two together. Yeah, buddy? Okay, Graham, we'll bring it back over here, please. So 2x times x squared and 2x times 9. So we're going to get 2x cubed. And if you multiply that, and then the 2x times the negative 9 minus 18x. And that's your first part there. And then the other side, where 2x times x squared is 2x cubed. So we're going to have minus a 2x cubed. That's my numerator, a little bit simplified. That's the part that has to be 0 for the whole rational expression to be 0. Cool thing is these are opposites. You get some cancellation. Negative 18x is all we have left, equal to 0. And when that happens, you just know that x is 0. Done. Alright, so that's what we're going to go from. And actually, what I'm going to do is just delete that little piece, save myself a little... Wait a second. I'm going to delete just that little negative 18, and I got this thing. Okay, so negative 18x equals 0, then x equals 0. That's my first critical value. The other critical values come from setting any part of your derivative that has a denominator. Hi, buddy. Did you say hi to my class? You say hi?
Hi!
Oh, not too close. It's a little bit loud. Thanks, dudes. And what you're going to look at is just the denominator equal to 0.
Hi!
Yeah. So that denominator right there, set it equal to 0. So x squared minus 9. I have some boys on my arm, so if it looks a little scribbly, yeah, hang on, boys. We're going to finish this up. So there it is, equal to 0. And if that's going to be equal to 0, do you notice that, we can take the square root of both sides. We can take the half power of both sides and get rid of this squared. That's a good algebraic technique. And if you do it to the 0 over here, which we have to do, it'll make that still 0. So we're dealing with x squared minus 9 needs to be 0. And if you add 9 to both sides, you get x squared equals 9. And if you square root, you get plus or minus 3. Those are we have our critical values.
on your eyeballs.
Ethan, let's not talk. No yucky talk, please. So we have 0 and plus or minus 3. Those are all our critical values. Now we need to get the graph and then talk about intervals of increase and decrease. Okay, so if I look at that graph to go along with my particular functions and I think about my critical values, I can see them in there. So let me go with my big blue marker. I definitely see my 0 has some interest in there. And then plus or minus 3 ends up manifesting itself as these, vertical asymptotes, these places here in the graph. Okay, and then if I finish this out, the big deal is now I got to do increase happens where the graph is going uphill, and I notice some uphill regions. I'm going to highlight them in green. So uphill, definitely right there, and uphill right here as I move left to right. Those are my two increase regions, and that's negative infinity till that critical value of negative 3. That's an increase, comma. And then the next interval of increase is from -3. Because the graph has a break in it, you have to acknowledge that. Then till 0, my other critical value. Do you notice those critical values end up being our end points, our end caps to things that are taking place? Okay, so then we're going to go to decrease, intervals of decrease, where it's going downhill. And anywhere it's going downhill, let's choose a favorite color today. Let's go. Yeah, let's do something kind of. Yeah,
I want
we'll
to do blue,
reddish or
Dad.
yellow. Hang on, buddy. Yep, we're going to do yellow. So there's decrease on that one and decrease over here on that one. Kind of yellowish. Those are the two chunks there. And decrease happens from 0 till that critical value. Remember, the interval is from what time to what time is it going downhill. I just highlighted the downhill regions. The x values that encompass it, that kind of enclose it, are 0 to 3, comma, and then 3 to infinity. Those are our intervals of decrease. There you go. That's the help for that problem. Let me know if you have other questions.